In this video, we're going to go over how to determine the critical values of a function, as well as determining the horizontal tangents of an exponential function, as well as a trigonometric function. In question number 1, we're told to find the two critical values of f of x is equal to x to the power of 4 over 5 multiplied by 7 minus 3x. Now recall, to find the critical values of a function, all you have to do is take its derivative and set it equal to 0. First of all, I noticed that we have a product of two functions over here. And so if you really wanted to, you could go ahead and expand this in here. However, I'm going to go ahead and use product rule. Recall that product rule tells you that you have to take the derivative of the first function multiplied by the second function plus the first function multiplied by the derivative of the second function. So the derivative of the first function, x to the power of 4 over 5, we're just going to use a simple power rule by taking this exponent, bringing it to the front, and then subtracting the exponent by 1. This is going to give us 4 over 5 multiplied by x to the negative 1 over 5. And then multiplied by the second function, which is 7 minus 3x. We're now going to add this and multiplied by the first function, which is x to the power of 4 over 5, multiplied by the derivative of the second function, which will just be negative 3, using a simple power rule. Now, if we try to simplify this, I see that I have an x to the power of 1 over 5 here. I could simply just change this into 1 over x to the 1 over 5. So let's go ahead and do that right now. This is going to actually give me 4 divided by 5x to the 1 over 5. And then we still have this 7 minus 3x here. And make sure you leave it in the brackets. And then we also have this laying around over here. I'm going to go ahead and simplify it and just bring this negative to the front and say that this is equal to minus 3x to the power of 4 over 5. Now, to find the critical values, all you have to do is set it equal to 0. However, we do not have a common denominator right now, but we can fix that by looking at what our lowest common multiple is. Right now, our lowest common multiple is 5x to the 1 over 5. So we can say that our LCM is equal to 5x to the 1 over 5, and I'm just going to multiply this term by the lowest common multiple as well. This way we can write it all over one common denominator. And so I'm just going to go ahead and expand this right now. So this will be 28 minus 12x, and then multiplying negative 3x to the power of 4 over 5 multiplied by the lowest common multiple. Well, 3 times 5 is 15. And then when you add these two bases with the powers together, it is 4 over 5 plus 1 over 5, which is just 1. And so this is just minus 15x. Now simplifying this even more, we get 28 minus 27x, all divided by 5x to the 1 over 5. Now we can go ahead and set this equal to 0 and solve for our critical values. So our first set of critical values is going to be when the numerator is equal to 0. So this will be 0 is equal to 28 minus 27x. And then we can bring the 27x to the other side and say 27x is equal to 28, where x is equal to 28 over 27. Our other critical value is going to be when f prime of x does not exist, and this is going to be when the denominator is equal to 0. And solving for x here, we're just going to get x is equal to 0. And so therefore, we can say that our critical values are simply just going to be x equals 0 and x equals 28 over 27. In the next question, we're told, for what value of x does the graph of f of x equals e to the x minus 7x have a horizontal tangent? Once again, to find the horizontal tangent, what that means, for example, if I had a parabola and the graph looked like this, at this point right here, I'm actually going to have a horizontal tangent where the slope is simply just equal to 0. And remember that your slope is also equal to the derivative, f prime of x. And so to do this, all we have to do is take the derivative of f of x and set it equal to 0. So this is going to give us f prime of x is equal to e to the x, because the derivative of e to the x is just e to the x, and the derivative of minus 7x is just minus 7. We can now set this equal to 0 and say this is equal to 0 equals e to the x minus 7, where e to the x is equal to 7. And then you now have to solve for x. To do this, we can take ln of both sides. And remembering your logarithm rules, we can simply take this x and bring it out to the front. And so this will be x ln e is equal to ln 7. And ln e is pretty much just equal to 1. So there's no point of even including it. So really, x is just equal to ln 7. And so as you get more comfortable with this, you can simply just go from this step all the way to this step. Now in this question, we're told to find the two values of x in the interval 0 to 2 pi, at which the graph of f of x equals x plus 2 cos x has a horizontal tangent. Once again, all you have to do is find the derivative and set it equal to 0. However, now we have a trigonometric function where we're having an interval, and so we need to keep that in mind. We're going to have two horizontal tangents, and we will need to use cast rule for this. So let's go ahead and find the derivative. We can say that f prime of x is equal to the derivative of x, which is just 1, and then the derivative of 2 cos x, well, that is just going to be 2, because the 2 is just a constant multiple, and the derivative of cos x is just minus sine x. And so I can go ahead and simplify this to 1 minus 2 sine x, and then we're just going to set this equal to 0. And bringing the 2 sine x to the other side, we're going to get 2 sine x is equal to 1. And isolating for sine x, we're going to get 1 over 2. Now your job is to isolate and solve for x. So recall from cast rule, we see right here that our sine ratio is positive. And because it is positive, it means that this can land in either quadrant 1 or quadrant 2. So this is quadrant 1, and this is quadrant 2. And so the first angle in quadrant 1, we can just call that something like alpha, and that is just going to be equal to x. And then for quadrant 2, our x value is just equal to pi minus the alpha value. And so to find what the x value or the angle is going to be in the first quadrant, all we have to do is take inverse sine of this. And so we can say that this is equal to alpha is equal to arc sine of a half. And so that is equal to pi over 6. And so this is your principal angle. And so in quadrant 1, we said that x is equal to alpha. And so our x value is just going to be pi over 6. And in quadrant 2, we said that x is equal to pi minus the alpha value, which is going to be pi minus pi over 6. And so that is simply just going to give us 5 pi over 6. And so therefore, we can say that we have two horizontal tangents at these x values, when x is equal to pi over 6 and when x is equal to 5 pi over 6 within the interval 0 to 2 pi. Now let's say that the ratio here was a negative. Well, instead of it being in quadrant 1 and quadrant 2, it would just be in quadrant 3 and quadrant 4 instead, where sine is negative in the tan and cosine region.